Hello everyone and welcome. In this video, I'm going to talk about the queue data structure. So this is a data structure that follows an idea called FIFO, and this stands for first in, first out. And it essentially means that the first element that you add into the queue is going to be the first element that you're going to remove or process. So let me give you a real life example here of a line to the movies. When someone arrives, they go to the back of the queue, right? To the back of the line. And when a person is done buying their tickets, they're going to go away, right? They're going to be removed from the queue. Now, a queue data structure is the exact same thing. You can only really add people to the end of the line or to the end of the queue, and you can only remove people from the front of the queue. And this is how a queue data structure works. Now, how do we actually implement this? Well, we can implement this using a linked list. However, I'm going to be using an array just because it's a little bit simpler and you don't really have to have any prior knowledge. So this array is going to represent our queue. Now, how do we actually implement this behavior? Well, we're going to have two variables, a front, which is going to be the front of the queue, and a back, which is going to be the back of the queue, right? The front is going to start out at the first position. The back is going to start out at outside of the queue, right? So if you want to add an element, you're going to add to the back, right? So you add an element here, for example, you grab the back and you move it over, right? You want to add an element here, you grab the back, you move it over, and you can't really do this to the front of the queue. So for example, if you want to add all of these elements, now the back is going to be right there, right? And this is how you add elements to the queue. Now, if you want to remove an element from the queue, you just grab the front and you move it over. You don't really need to do anything to this element because the queue only really exists between the front and the back, right? So these elements in here and here are not really going to be inside of the queue. And for that reason, you don't actually need to remove this element from memory. You just leave it there, but it is no longer in the queue, right? Now, how do you know if your queue is empty? So imagine that you have this disposition. For example, the front is here and the back is here. You're going to remove this element, right? So you grab the front, you move it over, and now only this element is inside of the queue. And we're going to also remove it. So we grab here the front and we're going to move it over. And now our front has surpassed our back, right? Our front is actually in front of the back. That doesn't really make sense. And so when this happens, we know that the queue is empty, right? Because it doesn't really make sense. So this is the verification you have to do in order to see if the queue is empty or not. Now consider this position. We're only going to have one element at the back of the queue, and both my back and my front are going to be pointing at that position. What happens when I want to remove this element? Well, I grab my front and I'm going to move it over, right? However, this position is not a valid position of the array. So what do I do in this case? Well, that's totally fine. I just grab the front and I move it here to the beginning of the queue, right? So now I have essentially removed this element, and instead of going outside of the bounds of the array, I went back to the beginning. So this means that the queue is going to be a circular data structure, right? When you don't really have any more value indexes, you just go back to the beginning. All right, so that is the implementation of the queue. Now let's actually write this in code. All right, so let's get right into it. I'm going to represent my queue with a struct like so. In here, we're going to have a couple of attributes. First, we're going to have the front of the queue, the rear or the back of the queue, and then we're going to have a capacity, which is essentially going to be the size of the array, which is going to represent our queue. And then we're going to have the queue itself, which is going to be an array of integers. All right, so first of all, let's define here a constructor. This is going to take in a number c or an integer c. And in here, we're going to define everything. So first of all, the front is going to be 0. The rear is going to start out at -1, so out of the bounds of the queue. And the capacity is going to be this c that we pass in here. And then the queue itself is going to be an array allocated on the heap with the size c that we pass into our constructor. All right. Then, since we're allocating this on the heap, we can also have here a destructor queue like so. And in here, we're just going to essentially delete the queue from memory. Oops, not like this, like that. if you don't understand what this means, don't worry, this is not really important. It just basically takes your queue and deletes it from memory since we're allocating it on the heap. All right, then we're going to have a couple of methods. First, we're going to start with the boolean isEmpty. This is going to check if our queue is empty or not. And in order to do this, I'm just going to return here the front is bigger than the rear, right? Because if the front surpasses the back of the queue, that means that the queue doesn't really have any elements inside. All right, now we're going to get to the methods that actually are important. So first of all, we're going to have here an enqueue. So enqueuing means adding an element into the queue. This is going to take in a value, the new value that we're going to put inside of the queue. And first of all, we need to check if the rear is equal to capacity minus 1. Then that means that the queue is going to be full, right? Because as I said, you can only put the capacity minus 1 elements inside of the queue. So in this case, I'm going to see out here, first a \n, and then queue is full like that, and another \n, and I'm just going to return like so. So if the queue is full, I'm not really going to do anything. If it's not, I'm going to say queue plus rear is going to be equal to the value like so. So essentially, I'm going to increment my rear, my back for the queue, and I'm going to insert the value there because I can only really put elements in the back of my queue, right? So I hope that was easy to understand. Now let's get into the dequeue like so. This is going to remove an element from the queue. That's called dequeuing, right? And the first thing we're going to check here is if this dot, and let me check here, is empty. So if the queue is empty, it doesn't really make sense to remove an element from the queue. So I'm going to see out \n, queue is empty, !, \n like so. And I'm going to return -1 just as a code to tell me that nothing really happened, right? And otherwise, let's actually do the dequeue process. So I'm going to create here a value. This is going to be the queue front, essentially the value we're going to remove, right? Because we can only remove elements from the front of the queue. And the reason why I'm doing this is because usually when you remove something from the queue, you return that value, just like a pop method, like a normal pop method would. Then I'm going to say the front is equal to the front +1. So we're going to move the front, but we also want to return the front to the beginning of the array if we have reached the end, right? So in order to do that, I'm going to say that this is going to be the remainder of front +1 by the capacity, right? And I'm going to explain in just a moment why I'm doing this. Then, of course, I'm going to decrement the rear, and then I'm just going to return here the value that I just dequeued. All right, so let me explain here this line. So I'm going to open here my whiteboard. And imagine that my queue is going to be this array right here. And imagine as well that it has 10 positions. So here is 0 and here is 9, for example. Now, when you calculate the remainder of something by 10, so the remainder of n, for example, by 10, this is going to give you a number between 0 and 9, right? Because if you divide 10 by 10, that's just going to give you 1 and the remainder is 0. So if the front +1 falls inside of any of these indexes inside of the bounds of the array, it's just going to be a number between 0 and 9, and it's just going to remain the same, right? For example, if front +1 is equal to 8, 8 modulus 10 is going to be just 8, right? The result is going to be 0, the remainder is going to be 8. And that is true for every number between 0 and 9, essentially. However, if our front +1 falls outside of the array, so for example, at the position 10, now the remainder is going to be 0, right? Because 10 remainder 10 is going to be 0, and the result is just going to be 1, right? So what this does is it actually grabs the front and puts it to the front of the array, right? It basically creates a circular motion of the front pointer, so that when it reaches the end of the array, it just goes back to the beginning like I told you, right? So that is why we're doing that line right there. So I only have 2 more methods to show you. The first one is going to be a void, is going to be called getFront, and this is going to get the front element of the queue. I'm actually going to go up here and grab this because it's the same verification, right? If the queue is empty, we don't really want to do anything. And otherwise, I'm going to see out the queue at the position front and then a \n like so. So this is going to get the first element of the queue, the front of the queue, right? And you can also do this with the back of the queue, with an index in the middle of the queue, and anything you want. All right, so the last one is going to be a displayQueue method. This is just going to basically allow us to see our queue, to see the elements in our queue. It's the same verification once again. If the queue is empty, we don't want to do anything. Otherwise, we're going to iterate. So we're going to say int I is equal to front, I is smaller than or equal to the rear, because the rear is actually going to hold a value as well. And then I++, I'm going to see out my queue at the index I, and then a little separator, dash, and then an arrow like so. And in the end, I'm going to see out here a \n. All right. So I think those are all of the methods I wanted to show you. Now let's actually create here a queue. I'm going to say queue is equal to queue with a capacity of 10. So we're going to have a maximum of 10 elements here in our queue. Then I'm going to say queue.enqueue to add a couple of elements. Let's add, for example, 10. And I'm going to add a couple of elements here to my queue. And then in the end, I'm going to call here my displayQueue to see what it gives us. Let me pull this up. All right, and there we have our queue. Now let's call the dequeue method. This is hopefully going to take 10 from the queue and return it. So if I run this, there you go. Now 10 is no longer in the queue, and 19 is also not in the queue. Let me see what that is about. Hey guys, so I made here a mistake. This is not supposed to be here. I don't know why I did this. I guess I was thinking about removing from the end, but we're actually removing from the front. We're not supposed to decrease the rear, right? So hopefully now this is going to work. Let me run that. And all right, so now 19 is over there. Perfect. So I apologize for that mistake. It happens sometimes. The last thing I want to do is get here the getFront method and call that. And I'm going to run this like so. And this is going to get 15, the front element of the queue. Perfect. So once again, I apologize for the mistake, but essentially that's all I wanted to show you in this video. These are the most important methods here in the queue data structure. I hope this video was helpful. If it was, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next one.